Good morning, everyone. Thanks for taking time to join this webinar. The topic today is going to be around low carbon heat solutions, particularly geothermal and mine water heat recovery. We're joined today by two speakers with over 20 years experience in groundwater and in the geothermal space. Conor Lydon from Tetra Tech, who's head of groundwater and geothermal, will be taking us through a sort of walk through of how geological and hydrogeological conditions can be used as potential for energy capture. And then later in the webinar, Gareth Farr from the Mining Remediation Authority will be talking us through the current and potential usage of mining assets to harness geothermal energy. And then, as mentioned previously, there will be some time at the end for Q&A. And as mentioned, if you'd rather drop some questions in the chat as we go through, we can address those as we go along. But yeah, and then my name's Tommy Walker. I'm Principal Engineering Geologist at Tetra Tech. I'll be hosting the webinar. Yeah, so this first slide, I just wanted to sort of give some background context. I'm sure, as you're all aware, the sort of situation at the moment where energy supply and is a huge talking point at the moment, but particularly in the geothermal space. Earlier this year, there's the first sort of power plant from deep geothermal was opened in Cornwall, and then there's the figure to the right of that just shows the proportion of different types of low carbon sources, which has come from the Department of Energy Security as of 2025. I just sort of wanted to highlight that heat pumps as part of that, making up what seems like a small fraction, but I think the main point that I'm taking from this is the potential in this space, and how fortunate we are to have sort of two technical experts to walk us through the potential of geothermal in the UK, but particularly in the Northern Ireland and the northeast of England. I'm going to hand you over to Conor, who's going to talk us through geothermal energy and its potential usages.
Thank you very much, Tommy. And yes, thank you to ACE to allow me to speak this morning. So what I'm going to do is just talk us through some of the fundamentals really around what geothermal is, what the potential is across the UK and Ireland. And really, I will showcase the potential that I've witnessed through the aquifers and resources that I've been exploring over the last 20 years. And I think that will line us up well then for what Gareth will present later on the mine water opportunity. So I thought I would start fairly simple with what is geothermal. So most of us, when we hear the word geothermal, we think of the big geysers in Iceland or steaming landscapes in New Zealand. Not quite the rolling hills that we have in the UK and Ireland, but there is really good potential across the UK and Ireland for shallow geothermal in particular, and there are some parts of the country that have good potential when it comes to deep geothermal. So we'll touch on both of those a little bit as we go through the presentation. So to try and help me illustrate the types of geothermal that are available, this is a really good graphic produced by the BGS back in 2022. So taking it from the left of the image, you can see that you have open loop ground source heat pump type systems, and you have closed loop ground source heat pump arrays, and then mine water energy. So most of my career over the last 20 years, I've been working on open loop, shallow geothermal systems, and also closed loop geothermal systems within that sort of shallow environment. And Gareth will obviously speak to us about the mine water energy schemes that he's been involved with also. Moving then to the right-hand side of that image, you have your hot sedimentary aquifer potential. So that's exploiting deeper geothermal opportunities, your depths in excess of 500 meters typically, and you're tapping into warm aquifers. And it's typically involves drawing out water from those aquifers that can be used then to transfer that heat to our homes and buildings. And as you mentioned, Tommy, in February of this year, we've had our first UK example of geothermal producing electricity. So that's the United South Downs project in Cornwall. And they're tapping into granites at depths of about 5 kilometers. So very, very exciting time within the UK to see all of those technologies really being applied. And we're starting to see the interest and desire to adopt these technologies grow and grow, particularly over the last 5 to 6 years, I would say. So why is it important? Well, we all know that our reliance on fossil fuel, like coal and oil and gas, have been impacting the planet, and fossil fuels essentially lead to the emission of greenhouse gases. Back in 2023, the United Nations for Climate Convention, that was the COP28 or COP28, the global leaders agreed to transition away from fossil fuels in energy systems. And as a result of that and earlier initiatives, a lot of nations across the world have been making binding commitments to reduce their carbon emissions and meet net zero over the coming decades. We have made amazing strides when it comes to decarbonising electricity, and a lot of you will be working in or aware that we've seen a massive increase in wind generation and feeding that back into the grid, and solar generation as well. And there's other energy systems like nuclear that all feed into that patchwork quilt of electricity that we can feed back into the grid. The challenge we have when it comes to heat is it makes up about 18% of all our greenhouse gas emissions across the UK, and it's quite difficult for us to decarbonise. One of the reasons for that is a lot of us have our own homes, we have our own central heating systems, so to decarbonise en masse is quite challenging. Unlike in Europe, where they have a higher proportion of apartment buildings, they can decarbonise multiple properties in a quicker way, because they can implement geothermal systems and then decarbonise multiple apartments or multiple buildings all in one go. Gareth will showcase what the potential is on the mine water side, and it has the potential to be massively influential in terms of decarbonising and shifting that dial multiple properties in one system. So it's a very, very exciting space. I wanted to highlight some of the benefits of geothermal. So it's a clean technology, it's renewable. It tends to be quite local. What I mean by that is the access to the potential tends to be within the area that you're looking to have your development, rather than the heat being generated further away and then transported to your location. So that's why we'll come on to the geology and the hydrogeology and why that's important, because you're effectively looking at what the potential is below your site. It can be used for both heating and cooling purposes. It can be cost effective. It's available 24/7, so it provides a really good base load, and it's not weather dependent. It also occupies a very small footprint relative to other technologies, and I'll show you an example of what that might look like. And in the current economic climate and geopolitical climate, where we have a lot of uncertainty and we have the war between the US and Iran currently, geothermal has the potential to offer real energy security and energy independence really here in the UK and in Ireland. So I wanted to just give you a flavour of what the potential was. The BGS and other similar departments like the Geological Survey in Northern Ireland and the Geological Survey Ireland have all produced really great maps to help us understand what the potential is across the UK and Ireland. So what I've put on the screen for today is I've just focused in on the open loop and closed loop potential within that sort of shallow environment across GB. And these maps can be used to understand what the potential is within your area for those two types of systems. So with your open loop, you're effectively drilling boreholes into the ground and abstracting warm water, and you're extracting the heat from that water. For a closed loop system, you're still typically drilling holes into the ground, but you're extracting the heat by installing pipework in the ground and effectively almost creating a radiator in the ground that absorbs that heat and allows you to take it back up to the surface. So there are some really, really good resources available to us showcasing what that potential is. And whilst I focused in on this sort of shallower environment today, we also have maps showing that sort of deeper geothermal potential. And Gareth will no doubt touch on the mine water potential as well, which can be isolated and looked at in its own merits. So how do we access the heat? Well, here's an example of a system that we were working on over the last couple of years. And typically we're drilling boreholes, and the footprint can be quite small. So in this case, this was one water well borehole. And we can limit the footprint of that to 1 or 2 meters, where we can excavate a hole in the ground, install a chamber before we start drilling, and then set up a rig over that and construct the borehole. Typically depths are 100 meters plus. That would be fairly typical. We do see geothermal boreholes typically within about 150 meter range. The reason for that is there's lots of really great drilling companies that have the ability to go to those sort of depths quite comfortably. Once you start getting beyond the sort of 200, 300 meter depth range, it becomes, the pool of capability starts to narrow slightly. But yeah, there's some really great companies out there that are very, very active in this space. Also wanted to highlight that there are other shallower geothermal options. So if you have space within your property, and that could be, an academic building that has like a green space in front of it, that shallow environment can be used, and you can install like a slinky loop type system within that open space, and then connect that back to heat pump technology that allows you to boost the low grade heat up to a usable temperature. So I've showed a borehole in the bottom left-hand side of this slide with a series of pipes coming out of the top of it. So again, it just illustrates the small footprint that some of these boreholes can occupy. And the pipe work is effectively, this was a closed loop borehole where the pipes are installed into the ground, and there's a carrier fluid. Typically that's a glycol circulated within a field pipework system that efficiently absorbs the heat in the ground and allows us to take that heat back up to the surface where we can make more use of it. So that sort of brings us neatly on to heat pumps. So most people, without knowing it, will have heat pumps in their home already. And it's a really, really efficient technology. So most people are using heat pumps in the form of a refrigerator. So what the heat pump does is it moves heat, or it pumps heat from one location to another. And in the case of your refrigerator at home, if you have cooked some food and you place leftovers within the fridge is designed to pump that heat, that waste heat from the food, and push it somewhere else. So if you've ever felt at the back of the radiator or the warm air coming out from around the refrigerator rather, it's the fridge is effectively trying to expel that heat and move it to a more usable location, which is into your kitchen. Well, the heat pump technology that's available now can take that sort of low grade heat from the ground, and it can elevate it to much more usable temperatures within a home or building setting. So effectively, you're transferring that heat from the ground to your desired location. And I should say, before I move off heat pumps, relative to other fossil fuel driven technology like oil and gas boilers, the efficiency of heat pumps is very, very impressive. And it's a technology that has been widely used across the world for many, many decades. And in countries like the Norwegian countries, in Norway, Sweden, Finland, this technology is very widely adopted, in excess of 50% of all homes being heated in some of those Scandinavian countries. And again, very high proportion or very high use in Germany and other parts of Europe as well. So I mentioned at the beginning of the talk that a lot of my time over the last 20 years has been focused on the shallower geothermal, so that's less than 500 meters depth. And principally, I've been exploring the geothermal potential within sedimentary aquifers. So I'm going to just give 2 or 3 examples today of projects that I've been involved with. So this first example is a university in Belfast in Northern Ireland. It was a 6,500 square meter building. It was purpose built over the last few years. It was a teaching facility with lecture theatres, seminar rooms, computer labs, office spaces, cafe, etc. And this building used a shallow closed loop geothermal system. So we oversaw the construction of about 40 closed loop geothermal boreholes. They were all drilled within the sort of green space in front of this building. And after the boreholes were drilled, we were able to cover that over with grass and conceal the boreholes below ground, because once the boreholes were drilled and those pipes that I showed you in an earlier image were put into the boreholes, everything was then connected up and covered back over. We don't need access to those boreholes again, and all going well, those boreholes could be there for the next 100 years and never need any maintenance or anyone to go back and get access to them, because they're completely sealed units. All the moving parts really are then restricted to a plant room within the building. But that borehole system has now been in operation for the last 3 years and successfully maintaining the building temperature for that academic institution. The other example I wanted to just mention is an open loop system that I was involved with. So we saw this right through from feasibility to construction and operation. And this was an open loop system. So that involved drilling water well style boreholes. So rather than drilling lots of boreholes and sticking pipework into it, we're drilling slightly larger water well style boreholes. We will put a pump into the ground via the borehole, and we will draw the water from that aquifer out of the ground. We then use that water, we use the heat within that water to transfer it to the building. And the boreholes that we drilled for this particular scheme were about 120 meters in depth. And that system has been successfully operating then over the last 7 years. Over the last 5 years, I've started to do more work on deeper geothermal options within that sort of sedimentary environment as well. So we have 3 projects at the minute at different stages of the process. We've taken projects from the feasibility, the pre-planning, pre-construction stage, and we're hopeful over the next few years that we'll start to see some of those come to realization and get them through the construction phase. But I've selected one example, which was a borehole drilled in Southampton in 1981. So this was a borehole drilled 1,800 meters deep into the Wessex Basin, where you had very warm water at 76 degrees centigrade. So most of us, if we're having a shower in the morning, the water will be coming out of the shower head at about 37 degrees. I know myself, if I accidentally turn that up slightly and it goes to 40 degrees, I feel like I'm almost being scolded. So to have a warm water at 76 degrees, below Southampton, is a really great resource. And in it was 1983, I believe, or 1986. They commissioned that borehole and started pumping that warm water out of the ground. And since then, the scheme has continued to grow and expand, and it now heats government buildings, a shopping centre, a hospital, a local university, offices, and more than 1,000 houses. So I just wanted to show you what 1,000 houses looks like. It's quite an impressive output from just a single borehole. Now that water is still boosted, in temperature further using an industrial scale heat pump. And the top right image really just shows the length of a sort of 180 meter car park. So the 1,800 meters that had to be drilled, it's equivalent to walking that car park about 10 times really. So some really good potential, and some good demonstration sites as well around the UK and Ireland, showcasing what has already been achieved and what the potential are for other schemes. So like anything, there are challenges as well. So we have found, or I've certainly found over the last 20 years, that it's a continual education requirement when it comes to discussing these opportunities with customers. A lot of customers are used to appointing an engineer to design a heating system, and we know from the statistics that oil and gas, particularly gas within GB, is the predominant sort of source of heating across the industry, and it's very easy to, in a well-established industry, to install a gas heating system. When you try and install a geothermal system, there are a few additional things that you need to think about. So one is, how do we get that heat out of the ground? Yes, we've got a great resource below our site, but there are inherent ground risks associated with drilling. So having competent advisors around you, be it geologists, hydrogeologists, and drilling companies, to help you navigate those risks and make sure that you get your boreholes into the ground and you have that connection with the resource that you're trying to tap into is really important. That also brings about some upfront costs associated with that construction that you wouldn't have in your sort of typical gas and oil boiler system. However, the difference when it comes to operational costs swings back in the favor of geothermal. So I showed the heat pump concept on the screen a few slides back. And what is important to note is that heat pumps are highly efficient. So in a lot of cases, for every unit of electricity you put into the heat pump to operate it, you're getting 3 and 4 units of heat out. So comparing that to a gas boiler, which will typically operate just below 0.9 of efficiency. So for every unit of well, think of it in monetary terms, for every pound you put into the gas meter, you get 0.9 units of heat out. Well, compared to a heat pump, for every pound you put into the meter, you get 4 units of heat out. So you can see how once you've constructed your system, they're relatively low maintenance in terms of operation, and the cost of running is very low. So in the last 3 years, I've been involved with a large demonstration project. It was the GeoEnergy contract delivered by the Department for the Economy in Northern Ireland, with support from the Geological Survey in Northern Ireland. And this project set out to showcase what the potential of geothermal energy is, and raise awareness amongst the public, try and educate key stakeholders, build market confidence, and it involved drilling on one of 2 study sites, and doing wide-ranging surveys and assessments to enable a deep geothermal scheme to come forward as well. So the shallow geothermal drilling and testing was very successful, and it's allowed us to gather lots of really valuable data that has been made publicly available to try and help future schemes. And as I say, all of the deep geothermal exploration work as well that has been done, that will enable and unlock other future schemes from the deep side of things. We've also used the likes of virtual reality to help communicate what the opportunities are, what geothermal is, how you access it. So that was a really great initiative to try and bring what is often a hidden resource to the public and allow people to better understand what the potential is. And as part of that geoenergy contract, we also set about trying to highlight what the career opportunities were. So they're wide-ranging across the different stages of the process. So at the pre-construction stage and that planning stage, there's a wide range of inputs that will be required from engineers and geoscientists in particular, but also manufacturing companies, drilling companies, project managers, and it's a really fantastic time to get into the geothermal space, given the growth that we've started to see over the last 5 years. And even at the construction phase and operational phase, I've listed a number of the roles that are typically involved during those schemes. So hopefully that gives you a good overview of what geothermal is, what the potential is within the UK and Ireland, and where you can maybe access some resources to learn more. And I'm going to hand to Gareth now to talk us through what the mine water potential is.
Conor, just before we start with Gareth, Alessia's just put a couple of questions in the chat. Would you mind answering them now, or would you rather address them at the end?
Yeah, I'm not sure I can see the questions.
No, I've got them here. So Alessia's first question was what drilling techniques are generally used, or combination of techniques used to drill the deep boreholes, if you know.
Yes, so typically you would be using a rotary rig. That can be, well, depending on whether you're drilling for an open loop geothermal system, you might be using like a reverse circulation rotary rig, or you might be using down the hole hammer techniques. There are lots of different methods that can be used to drill open loop geothermal boreholes, but typically they adopt a similar approach to when you're drilling a water well. When it comes to closed loop boreholes, you tend to use mud rotary because the formations might not be as competent, or you're trying to drill as quickly and efficiently as you can, and you're effectively putting you're trying to open the hole so that you can get your pipe work in and then seal everything back up. So mud rotary tends to offer a lot of benefits because it can work through some unconsolidated material as well. When it comes to the deeper geothermal environments, you are into much larger rigs. We have been exploring rig options on a number of the deeper geothermal schemes that we've been involved with, and some of the rigs are akin to what you might see on like an oil and gas platform. They're very large. They can be 40 to 50 meters tall, almost almost like a crane type structure. And those rigs are limited in terms of limited in supply within the UK. You're talking about bringing rigs from Europe or elsewhere, for those deeper schemes. But currently those are probably fewer and far between. But there are lots of good drilling companies out there that have this sort of shallower drilling capability within the UK and Ireland. And I would just one probably key point to perhaps take away is when it comes to shallow geothermal, there is good potential everywhere across the UK and Ireland. So there's probably no site that you couldn't install a shallow geothermal system on. It's simply a case of trying to understand what the best system is, whether it's open loop, whether it's closed, and that involves an assessment of the geology, the hydrogeology, to decide what the best technology fit for your site is.
Thanks, Conor. And there was a second one, sorry, as you mentioned managing risks when sort of implementing these solutions. Which is the most common risk that's often overlooked in this field?
So I've touched on drilling risk and uncertainty around ground conditions. So you're never guaranteed anything when it comes to with the subsurface. The one thing you're guaranteed is that it'll always throw up a few surprises. So it's having good experienced people around you to help you navigate that and still achieve a successful outcome. But I think the biggest risk is it's kind of communication and education, because not everyone understands the process that is involved with developing a geothermal system. So I think the biggest risk is not having good communicators along the way, and making sure that everyone involved in the process understands what needs to happen and when. So I think communication is really important, and if not delivered well, that can be a very big risk to a project.
Thanks, Conor. Yeah, that was excellent. Thank you for that. And yeah, so now we're going to hand over to Gareth Farr from the Mining Remediation Authority, who's going to talk us through mine water heat potential. Thanks, Conor.
Yeah, thanks, Tommy, and thanks, Conor. And good morning, everyone. Thanks for the invite to do this. I'll try and whittle through so there is some space for questions at the end. So my name's Gareth Farr. I'm the head of the heat team at the Mining Remediation Authority. So I'm going to cover a little bit about what on earth mine water heat is. Also, I've got a good focus on the northeast of England, because really at the moment it is, excuse the pun, the hotbed for mine water heat in the UK and possibly even in Europe. So I will take you through some fun slides now, and I'll look forward to any questions at the end. So Conor showed that great slide at the beginning about the range of geothermal types. So we're kind of here, we're sort of mostly focusing on what we'll call open loop schemes, but of course there's closed loop schemes across the coalfield. So like Conor said, you can do geothermal anywhere, if you like. You can do closed loop schemes pretty much all across the coalfield, but the ones I'm going to focus on are open loop schemes where we're recovering heat from water. So how do we get to that? Well, drilling boreholes. Here's us out with a drilling contractor in Gateshead. We also operate over 80 mine water treatment schemes across the country. So these are places we bring mine water to the surface to treat it. Now, lots of people see that as, oh, isn't this great? We're cleaning up the environment. And of course we are. But for us geothermal folk, we look at that and say, ooh, lots of heat in there. So there's these 80 locations that are big, nice sort of usable ponds of water. And there's also across Great Britain, there was historically tens of thousands of shafts and mine entries. Lots of those are now being made safe or not accessible, but there are remaining still some good shafts to be used, or some gravity fed discharges that could be harnessed as well. So there's the kind of three approaches. So let's go global. I often get the feedback, come on, we need more mine water heat schemes in Britain. I say, hang on. So let's have a look at the world. So if we have a look at the world, those countries coloured in red are all countries that have some form of coal mine water heating schemes. Of course, you can use other mines for mine water heat, but we're focusing on coal. And if you look through this ranking table, which I've slightly amended from a recent paper by Oplet et al., you can see Great Britain is actually fairly close to the top of this ranking, along with Germany and China as well. In fact, the Chinese do have more mine water heat schemes than this, but they actually use mine water from active coal mines to then put heat back into the coal mines that are cold. So I haven't included those on here, so I'm just including the ones that are used for low carbon space heating on this figure, but some really interesting work coming out of China. So that gives you a kind of global perspective. So let's zoom into the UK. So here, or GB, I should say. So here's a map of Great Britain. So apologies to the Shetland Islands. I have unceremoniously chopped you off. So if you are from there, sincerest apologies. The green areas are our coal mining reporting areas. These are kind of areas where we know we've got coal mine recordings. The small black dots are closed loop schemes. We've permitted several hundred of those across the coalfield in the last 20 years, but I do fully imagine there's probably lots more than that are in existence. But what you can see from here, these big red dots are operational schemes. I should probably be green dots, shouldn't they? But they're red dots in this case. These are operational mine water heat schemes. You can see a good little cluster in the northeast, and we'll focus on those, but some others elsewhere. The orange dots are schemes that are about to go live. They're just irritatingly in the very final stages of paperwork, commissioning, or other things, but there's some more exciting things to come along. There's also a few decommissioned schemes as well, some in Scotland and one in Wales. So you can see from that, actually, in Great Britain, we've been doing mine water heat in some format or another since 1999. So before the just before the millennium, those were two groundbreaking schemes in Scotland. Unfortunately, they're both decommissioned now, but they operated for several years quite happily. But the real focus of the last sort of couple of years is in the northeast of England. So without much ado, we shall zoom into the northeast of England. So here we are. So we are currently now looking at Gateshead. So Newcastle is just to the north. All the wonderful bridges over the River Tyne are just in the top west of that image. So what we've got here is actually some really exciting stuff going on. We've got Gateshead Energy Company, who are operating a 6 megawatt mine water heat network just in the top left. We've got two privately owned and run schemes at two Lanchester Wines warehouses just over on the right hand side. And because we've got numerous mine water heat schemes in one area, we also decided that this is actually a really opportune moment to see how these schemes interact, if they do, if anything is negative or positive. So what we did the other year is we constructed some boreholes in between, which we call the Living Lab boreholes, and I'll talk about those later. So there's a lot going on in this space, and actually it's probably one of the most exciting spaces I can think for mine water heat in the world, what with operational schemes and monitoring data. So let's have a look at some of them. So first off the marks was Lanchester Wines, privately funded, supported by Town Rock Energy and obviously Lanchester Wines, two big open loop mine water heat schemes. They do the honourable job of maintaining correct temperatures in two large bonded warehouses that clearly store a lot of wine for distribution. So thank you, Lanchester Wines, but also a really great use of mine water heat there. And a real trailblazer in this space. It shows the heat pumps, and here you've got the Ochrus mine water and the heat exchangers there down in the bottom right hand corner, those plates that are between those big green vertical metal sheets. Several megawatts combined there, total heat capacity. Then let's zoom just up the road slightly. So this is Gateshead Energy Company. This is an aerial view. You can see Newcastle in the north. This little blue box is where we drilled the boreholes. There's the mine water energy building itself. And there's the original combined heat and power energy centre. So they used to have a combined heat and power heat network, but in a couple of years ago, they decided let's move to mine water heat. So that's what I'll show you about them, replacing their sort of gas source primarily with a mine water heat source. One take home from this is the small box I first showed where the boreholes are actually incredibly small. There's only a handful of boreholes to support this 6 megawatt capacity scheme. So one benefit of open loop, but there clearly are challenges as well. So let's crack on. So a bit of background, Gateshead Council oversee it. It's owned by Gateshead Energy Company, a kind of spin-out company from that. And they repurpose this existing CHP plant. So they they asked for our assistance, and between 2020 and 2023, we helped them site boreholes, supported the drilling of them and the testing of them. They had various funding streams, partly council funding and also from UK government. And you can see the broad breakdown of costs there that went into creating this project. So probably most interest for us is 1.8 million on drilling, and we'll drill into that. Again, another horrible pun shortly. So what we're looking at, our borehole locations there are marked with little circles. It's a brownfield site, it's an urban area. We've got a mixture of mining seams there. We were targeting the high main, which is about 50 meters below ground, and the Hutton seam, which is 150 meters below ground. So not deep drilling. You can see from the ages of these seams, though, they are old. The take home from this is old seams tend to be less well mapped than modern workings. So therein lies a challenge in this area, in that actually a lot of the mine plans were pretty rough, and there was always going to be an element of unknown. Hydrogeology, I should go into depth more on this as I'm a hydrogeologist, but shallow water levels and tidally influenced to give you a concept of what's going on. Yeah, challenges, shallow workings, old workings, unmapped workings, all the classics. So what did we do? Oops, sorry. So we drilled lots of boreholes. In total, we drilled 12, 1.8 million was spent on drilling. Unfortunately, 7 of them were pilots, had to be abandoned. We knew about this uncertainty. It was unfortunate that we did have some we had to abandon, but we knew it was an area of poorly mapped mine workings. However, there was a range of successful boreholes that came out of this. So 2 abstractions, important, one for you've got resilience if you've got more than one abstraction borehole, a discharge borehole, a monitoring borehole, another one that kind of joins the seams together there to increase the flow rate. This is an image of one of the abstraction wells. You can see part of the rising main and a concrete O-ring, which is covered up with a manhole chamber and all grassed over with some solar panels near it now. So your footprint is incredibly small. I should give a shout out to Jim Gillen there, who's the energy manager at Gateshead Energy Company, a real trailblazer in this space. And we did pumping tests, and we pumped up to 140 litres per second, which I think was the maximum required and what was ultimately licensed by the EA. So I'll skip through this one quickly, but for all of you that have been involved in licensing or applications for groundwater abstractions or discharges, same applies here. And for all of you that have been involved in drilling into coalfields and getting permits, same applies here. But we also have a heat access agreement for these things. So we've kind of merged these processes together, but in effect, you do a lot of pre-construction things, so pre-application discussions, your water resources, 32 investigation consents, permit to drills from ourselves, got heat access agreement that kicks off, then you drill your boreholes, then you've got EA permission for pumping tests and discharges. Let's do our pumping test. Then we also have EA final licenses, MRA final licenses, and ultimately operation and monitoring. So that's kind of a streamlined version, but if you do want the detailed breakdown, there's a hyperlink at the bottom, or you can just have a quick Google of that or share the slides after. So there is a process as the take home, and that's a good thing. So what does Gateshead look like in this sort of very Mickey Mouse cross section? This is broadly it. Shallow workings, water levels 20-ish meters below ground, so there's not a huge pumping head. That's where the energy is going into these schemes, is pumping water up. If you don't have a huge distance to pump it, all the better. So it comes from the 2 abstraction wells, and then again it goes to the heat, the energy center. The thermally spent water is returned back underground, and the system circulates quite merrily. The idea with mine working schemes is you ideally do want 2 separate seams, and you don't want them to be able to have thermal feedback too quickly. And I think there's a small element in this scheme of some thermal deterioration, but nothing too significant. So yeah, that's what it looks like. This is a photograph and a building that got me incredibly excited. It is a shed, in effect, but has a large sign, mine water heat pump, on it. This got me personally incredibly excited, and it's wonderful to see that sort of big branding on it. The boreholes are just off site there, and you can see the solar farm that the council have put in as well, that at times can supply enough electricity to run the network, but obviously not always. So you can see it's an urban environment, industrial sites, and a lot of these buildings around are connected to it as well. So what does it supply? They've got, currently the council have got over 600 residential connections, 24 large buildings, so the Glass House, the Baltic, council offices, and some of these light industries down in the bottom right hand corner. So GB Lubricants is a really great case study of this. Their business is inherently hydrocarbons and lubricants. However, they've decarbonised their process by connecting to the mine heat network. So that's a really great story, and a very old company up in the northeast there. And the consumers currently pay 5% lower than gas. So I think overall, great success story. And of course, it's secure heat as well, which is very hard to put a price on. But like Conor said, with all the war and issues out in the Middle East, I think sometimes we're really bad at putting an actual cost on oil and gas. But there is a wider cost than just what we pay at the pump, if you like. So what else is coming up in the northeast? If you know Seaham on the coast, wonderful little place there. We have a mine water treatment scheme there. We pump from a shaft. Water comes out at 80 litres per second, 2 big bathtubs a second at 20 degrees. So what we've done there is seen that as an opportunity and worked with the council and various other partners, Carbon Homes, Ash Group, so on. And we'll be connecting that mine water treatment scheme to a large housing development. And what does that look like? Well, good news. There's work underway. This is the energy centre, which has been constructed. It was delivered in a modular format, I'm told, and put in place. Fortunately, I was there a few weeks just before that started happening, but that is there and in place. And some of the 750 social homes are being developed now as well, or being constructed, so they are there, and connections are being made. So I think watch this space. At some point in the very near future, it will be officially live. So super exciting times there for the northeast as well. I also failed to mention that there will hopefully be a leisure centre in the northeast coming online soon as well, but we've been asked not to speak about it too much, but I think I can safely say there's another scheme that will appear shortly. So let's go back to this sort of aerial view to wrap up the talk. We've got these 3 mine heat schemes. That's Gateshead, and these are the 2 Lanchester wine schemes. And we've got our living lab, which is our 4 monitoring boreholes in between. So we've been collecting data from these for over a year now. It's really exciting. Our main aim is to see what data we can get, see if there is any negative interactions or positive interactions, and how can that data be used to support sensible, evidence-based regulation and licensing. You know, is it a risk they're so close, or is it not a risk at all? Is it actually a benefit? And let's see what we can do and see how we can support both developers, people looking at these schemes and trying to understand them or license them or permit them, and give them hard evidence and data to show what's happening. So all that data is available on data.gov, or drop me a line after and I can point you to it. We've also just published a paper on our construction of this monitoring network as well, which is out in the Quarterly Journal of Engineering, Geology and Hydrogeology. Here's a little 3D model showing what it looks like. Again, you can see our monitoring holes in green and the operational holes in dark blue or black. But you can see they are in quite close proximity, and thus far I think it's safe to say we've not seen any negative interactions. We have seen, as you'd expect, pressure interactions when one site's pumping or not, and that's fine, but that's just pressure. It's like me and you talking in a room, isn't it? And you can hear me and I can hear you, but it's not necessarily a bad thing. So we can see them sort of speaking to each other, but we're not seeing any thermal impacts from one another. So that's, you know, a really positive sign, and we'll keep to monitoring these and publishing the open access data, and encourage anyone that wants it to talk to us. It's fine. So, wrapping up my talk, leaving hopefully 10 minutes for questions. What's next? A leisure centre in the northeast. Somewhere in the north, hopefully a general hospital will be drilled this year as well, which will be uber exciting, because who wouldn't want to give sustainable, secure, low carbon heat to the NHS? I can't think of many people. And ourselves, and also consultants working in this space, also have multiple feasibility studies going on. So there's really wide interest in this. Future opportunities. We're exploring mine shafts for quick wins. If you don't have to spend loads of money on drilling a borehole, great. That'll really change your economics of things. But there's not great shafts everywhere. So it might work in places, it might not work in places. We should have exciting news coming up soon about how we've looked at heat storage in mine workings, but this isn't all about taking heat. Can we put heat back into mine workings and use them as a thermal store, whether it's interseasonally or have two different schemes talking to each other, one that gets rid of heat, one that takes heat. And that sort of feeds into the sort of proliferation of data centers and their need to cool as well. I mean, we could quite happily use mine water for cooling of data centers, and it removes possibly objections to people using fresh drinking water sources or drinking water sources that are not available under licensing regimes. And probably to sort of hammer home Conor's challenges, upfront capital, always a challenge. Perception of drilling risk is often a challenge, especially when, but you can mitigate that by getting the correct people involved to explain the drilling process and educate people. And, you know, the wider education piece, I should really have put stakeholder engagement there, because that is key. And I think that's what I mean by it really as well. And ensuring there's a sort of skilled workforce being built up to deliver this technology. So there's my whistle stop tour. And thank you very much. Over to a quick round of questions, I think, Tommy.
Yeah, thank you so much, Gareth. That was excellent. I am just going to quickly, just stop the recording, and then there is a few questions in the chat which we can go through. But yes, thanks, Gareth.